So today at work, I showed off the video that I made yesterday about Hardened Malloc and about exploiting this heap overflow, and about how CFI can be used also to help prevent that mitigation. And someone at work asked me if there was anything that Hardened Malloc was able to do that the CFI couldn't do. So I came up with this this little bit more contrived example based on the heap zero that we saw yesterday. But instead of just having the function pointer point to winner, I'm going to put a conditional in saying that function pointer is going to point to winner so long as the first character of my input is not a lowercase a. So what that means is that if I run a program like, just make sure it's make. Okay. If I run the program with the command line argument of AAAA, it's going to run the no winner function. But if I run with a little a, it's going to run the winner function. So the idea is there a way in which we can overflow the heap to make FP run the winner function even though our first character in our input data is not a lowercase a? So let's go into GDB and see if we can do that. So enter into GDB and disassemble the main. And we're going to jump to that right after the string copy. And let's run some exploit code. So what we're going to do here is Python print, and we're using capital A, so it's not a lowercase a. And we're going to do 80 of those. And then we're going to inject where the winner function is. So let's look at object dump to find out where the winner is. And take a look at all the functions. Oh, need to put that where on H0. So here's no winner. Here's no winner CFI, which is for the control flow integrity, and the winner CFI, which is for the control flow integrity. But we don't see any normal winner function. So instead of grepping for just the functions, let's look for winner. And we do have something that's going to call the winner CFI. So let's just take a look at the entire object dump. And here's where winner is going to be called. And it's called from this type ID ZTS5 global address. So if you notice, this function, this type ID blah 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 blah, is very similar to the no winner without .cfi at the end. And it's the one that's going to call the winner CFI. So what's the winner CFI and what's the no winner CFI? Well, it's just the regular code of doing the printf of the thing that it's just the regular code that we would see, that we would expect if we didn't compile it with CFI. So let's go back into our GDB and grab that type ID function. So it's 4012D0. So 4012D0. And switch it for endianness. And give it a go. And let's take a look at our RAX register. So we've got our exploit and we've got our capital A's. So we should not be allowed to run the winner function here. We should have to run the no winner function. And because winner is in here, it's unexpected code or code that is not intentional to be run by the developer of this program. So if we continue on, we see, oh, we have passed this level. We did not we did not crash from an illegal call. We did not crash from sig.il. So let's go back to how the code was originally. And go back in. And let's take a look at the object dump again. So again, there's no winner here, but there is this guy here. And let's just go make sure that it's the one that we want. No, that's not the one that we want. How do we get the winner? Ah, it's not even in here. So we obviously can't call a function that isn't in, that's been totally taken out of the executable itself. So let's just make sure that winner's not here. Grep for winner, not winner, winner. And there's only no winner here. So we have to get that winner to not be stripped away. So let's say let's just try it to make sure that if fp is equal to null, then the winner function is called. Alright, and let's take a look. Is winner in here now? Winner is in here. And so here's winner. Here's the no winner CFI. There's nothing weird in it. Weird winner. And this type ID thingy global address is the only thing that's going to be able to call the no winner function. So disassemble main and get that breakpoint and run probably starts with 40. Where was winner again? Winner was right here. 1170. And take a look at RAX. And we've got our regular old exploit that should happen, except I expect an illegal instruction, and that's what we get. So that's because, well, to fully explain CFI, there's better videos on the internet, and I will put in the link below a good video on explaining how CFI works. But I just wanted to whip out this kind of contrived idea to get around control flow integrity in a contrived way. I'm not sure if this could ever happen. Well, it can obviously happen in real life because someone can do this. But I'm not sure if how risky, how often that's going to happen in production code. But it can happen. So let's see what Hardened Malloc will do when we have this CFI hole, I guess we can call it. So we got to get out of GDB and recompile our binary. And first we have to save, then recompile the binary. Jump into GDB, and we will LD preload and let's run the exploit. Python-c print, do a bunch of A's. It's not the lowercase a, so we should not be running winner. And in this case, how do we get to the winner function? We call this function at 4012d0. Now that is not something I was expecting to happen here. I was not expecting to pass the test here. I was expecting set environment LD preload to hardened malloc lib hardened malloc.so. Do we have code hardened malloc lib hardened malloc? It's right there. So what went wrong? It's using the it's using hardened malloc here, and we can see that in the info proc mappings. So here is where our memory is being allocated. So why am I passing the test? Oh, because it's, okay, sorry. There we go. We have to be not equal to A to make sure that no winner is the one that's called. All right. Recompile, back in. Set environ. Level has not been passed. So, in my opinion, even if you are compiling with the CFI sanitizer in order to make sure for code flow integrity, adding lib hardened malloc is still a useful library to add. Thank you very much for watching, and I'll catch you in the next one.